Uh, Hello, everyone. I'm Deep Medhi. I'm the organizer of this SKC Science and Technology webinar series. And today I have the pleasure of having Dr. Ranjay Krishna. And he is a very accomplished young man. He just finished his PhD from Stanford University in computer science. He's originally from Guwahati. And prior to doing his PhD, he has done undergraduate from Cornell University in electrical and computer engineering, as well as in computer science. In between, he has found time to do stints at Google, Yahoo Research, Facebook, MongoDB. And he has been doing some pretty cool research, and I thought it'll be fun to have him as a speaker. And so with that, I'm going to see, what he has to say and tell us, and keep it at a pretty, simple level. And as I said, this is more like a fireside chat. So with the fireside chat format, we are going to do it to the kind of an informal way of doing it. And so we'll go from there. Okay. So Ranjay, you probably have some slides. If you want to share, that's fine. And I'm also going to read questions from the chat as people post it at any time during the presentation. Good? ঠিক আছে?
ঠিক আছে.
Okay.
Okay, yeah, this talk will be pretty high level, but of course, if you have any questions, feel free to interrupt me and stop me at any point. Let me see. I just want to check if my slides are viewable. Yeah, everyone can see my slides?
Yes, I can see it. Good.
Okay, great. So usually this, what I have planned would take about 25 minutes or so. So, feel free to interrupt me at any point if anything is unclear. So I'm here to tell you about how we can design machines to acquire visual intelligence from human interactions. And yeah, the last thing is I can't see the chat. So of course, if there is a question.
I will read it to you,
yep.
Don't worry.
Great.
So, okay, I'll take care of that part. Okay.
Great. Okay, so I work in a field called computer vision, and computer vision typically for many decades has focused on understanding objects in the world. And objects are things that you see around you. So birds, cats, dogs, fish, all of these different kinds of objects that you have all around you, like the cup that I'm holding on my table, for example, the laptop, etc. Now, although over the last couple of years, computer vision has gone really good at identifying these objects, our world is more than just a simple collection of a set of objects. It's rich and it's vibrant, and people constantly surprise us with all kinds of new experiences and performances. They repurpose new items for new use cases. They find themselves in predicaments they never thought they would. We see them using equipment we've never seen and in ways that we've never imagined. And even animals end up surprising us with their fashion sense, as well as by their unexpected agency. Now, all of these new situations that I'm showing you, all of them are probably things you haven't seen before. But these new situations are completely commonplace, and you have no difficulty interpreting all these images and making sense and reasoning over them without any difficulty at all. Now, unfortunately, despite a decade of amazing advancements, most of the computer vision technologies, the machines that we're building today, they still struggle to truly understand this visual world. And prior work has noted many times that these models especially fail whenever they encounter concepts that are completely not included in their training. The way most of these models are trained is through a data-driven process where we present these models with training data, and then we ask them to be able to sort of operate in the real world. Now, if anything is ever not present in their training data, like for example, rhinos,
Ranjay, let me ask you a quick question, just so
sure.
Not everybody might be familiar with training data and test data. So
sure.
If you could quickly say what you mean by that, right? So.
Yeah, so typically we'll get into this a little bit later on, but the way we train our machines today is we collect large data sets. So for example, if we want them to recognize an elephant, we collect a lot of images and we would have labels associated with them that say that it's an elephant. Now, if these models encounter an elephant in the real world, they are able to recognize it because they can sort of make sense of this new thing that they're seeing as something they've seen in their training. So for example, if you teach a kid what an elephant is, and if that kid encounters that elephant somewhere later on, they'll be able to recognize it. But just like a kid, if that kid has never seen a rhino before and they come across it somewhere in the wild, then they're probably not going to know what they're looking at. And so that's the same problem that these machines have. Because they rely on their training data, they have no way of sort of extrapolating and understanding and recognizing new kinds of concepts that are not already present in their training. And this has been a big problem in computer vision for a really, really long time, and it's still completely unsolved. And I would argue that no matter how much data we try to collect and place in front of these machines, it doesn't matter, because at the end of the day, the concepts that we're teaching these machines to learn are constantly evolving over time. So for example, the computers that you have that we've collected in a lot of these training data sets that are released today, they look like the computers from the early 2000s. They're these cathode ray monitors that are really difficult to use, and today nobody has any of them, except maybe my grandma. My grandma might still have one of these computers. But today computers look a lot different. You've got Macs that are really thin and really nice, and similarly, even the phones that were collected in these training data sets, they look really different from the phones that we use today. So aside from that, there's also new kinds of products that are constantly invented and new kinds of species that are constantly discovered. And because our world is constantly adapting and growing and changing, anytime we train our system, it becomes obsolete the moment it's done training. And that's the biggest problem with all of the computer vision systems that are out there in the world. The moment they stop training, they become obsolete. Now, in comparison, people, when they encounter new concepts that they don't recognize, that they've never seen before, for example, when a child encounters something new, they ask for help. People don't learn in social isolation. We've seen many examples from social development theory that human development is quite a socially mediated process. And children acquire new beliefs about the world, they acquire new kinds of cultural norms, and they learn continuously throughout their entire lifetime by engaging in inquisitive dialogues with more knowledgeable members of society. People learn what questions to ask and how to ask those questions and how to pose them. And they learn which questions lead to new kinds of information by inferring new information from people's responses. They also learn what kinds of questions people actually want to respond to. So kids ask a ton of questions, and some their parents respond to and some they don't. And so over time, they also learn what questions will my parents teach me. And so learning this sort of social skill is very fundamental to how we end up growing. And it's something that I would argue is sort of required for machines to be able to grow as well. So enabling this sort of human-like visual intelligence, it's a challenging problem. It'll require us to completely fundamentally redesign how we train systems, but instead of training them from static training sets, by allowing them to train just like people in real social contexts. So just like people learn through social interactions with people, what I've been trying to argue for a few years now is that we need machines to similarly learn in social contexts as well. And to do that, they not only—
Let me ask you another question here, Ranjay. So how, in the context of images that you talked about earlier, there, of course, there's no hard to do what you will call it a social context, right? So, and with people, obviously, we can talk about that, right? I presume you're going to cover something about that later on. I just wanted to throw it out there to you. So,
right, yeah, we're going to talk about how you put machines out in real social environments and allow them to learn just like people.
Great. Okay.
Okay. So the fundamental thing that I hope we all sort of take away from today's sort of discussion is that if we want machines to learn in real social environments, they need to acquire some sort of social intelligence. And so over the last few years, inspired by how people typically learn, my research agenda has been pushing computer vision towards learning through human interaction. So learning by interacting with people in real social contexts out in the real world. So instead of learning through this sort of static way of collecting large data sets and using training data to train, I've been trying to move these agents outside of that training data set and learn in the real world. So more graphically, one way to sort of explain that is that today we'll talk about how we can design these agents to move outside of just learning from books to learning from real interactions with real people. So that's the analogy that I typically draw. So instead of having these machines learn from these curated books that we generate, they're going to learn by having conversations with people, by asking them questions, just like a child would ask questions to more sort of adults and knowledgeable members around them. Okay, so today there's a lot of things I wanted to cover, but we probably won't be able to cover all of them. But let's see how far we go. I really want to sort of talk about how we can design a framework for what I would call a socially situated artificial intelligence. And what I mean by a socially situated artificial intelligence is a system that can learn by interacting with real people out in the real world. And within this framework, what I'll hopefully show you is that we can design learning objectives that'll enable these agents to generate interesting questions that not only teach them something new, but are also interesting enough that people actually want to answer. And then finally, I'll show you some interesting results of things that an agent like this ends up learning when we actually end up deploying such an agent out in the real world. Okay, so we're going to look at some results as well, aside from just talking about it abstractly and metaphorically. Okay, but before we get there, let's actually take a little bit of time and think about what this problem really looks like. So as I was saying, the current way that a lot of AI systems today are trained, the way they're trained is they're placed in a room and they're given a lot of books to read. Okay, and these books can be anything from large amounts of data sets that people have collected or large amount of web scraping that people do. And whatever it is, they sort of collect this large data set and they present it to these models to learn. And the analogy that I like to use to explain this training process is depicted by this image here. You've got this robot that's trying really hard to learn and memorize everything so that eventually when it goes out of the room, it can operate and recognize everything. Now, for those of you who have kids, you know that simply memorizing things from a book is probably not going to make you understand things in the real world. So to really have things make sense for people, you need to have learning happen out in the real world, out with other people that they can interact with, that they can see, that they can talk to. And similarly, we want to do the same thing. We want to be able to move these agents completely outside of their training data and actually talk to people. And the idea is that whenever they do encounter something they haven't seen, like the rhino here, they can ask a question. So, for example, here, it can, if it can ask a question like, what is in front of the elephant? That would help it identify what it is, because someone might respond. And if someone responds, now you have a new piece of information. And when you have a new piece of information, you can now continuously learn throughout your entire deployment. Okay, so the main challenge of enabling something like this is really designing good questions. So learning how to interact with people, how to frame good questions so that you can eventually learn over time. That's the main challenge of enabling this kind of system. Now, the reason this problem is difficult is because some questions are just not informative. So for example, if I have a system that goes around in the world and looks at grass and looks at photos and always asks what color is the grass, it's probably not going to learn anything new if it's already learned what grass is. And similarly, some questions are just not going to receive any responses. So a question like, is the person sitting behind the person guiding the elephant holding their right hand or their left hand up to their eyes? That question is really long, it's really convoluted, and it's really difficult to understand. And you really have to think a lot before you can actually answer that question. So at the end of the day, people are lazy. They're not going to respond to such long, complex questions. And so what you need to do is find what are good questions to ask that people actually want to respond to. Okay, so these are the two challenges. So to summarize these two challenges, the reason this entire system, enabling such a system, is difficult is because you need to solve two problems at the same time. The first problem is interacting to learn. So you need to learn how to pose questions that'll teach you something new. And the second challenge is learning to interact, where you need to learn what questions people are willing to answer. If you don't solve both of these problems simultaneously, you're going to get agents that don't end up improving in the real world. So let me give you some examples of questions where if you don't learn how to interact, then you're probably not going to receive any responses. So for example, let's say that you have an agent and it's looking at images online and it sees these 4 images. Now, if it asks a question like, is that food? Chances are people are not going to respond to it because it's so obvious that it's food. You don't want to tell somebody it's food, it's obvious. So there's a lot of tacit information out there in the world that people just don't want to be able to answer. And similarly, there's other kinds of color questions that, again, people might not want to answer just because, again, it should be obvious to everybody. There's some kinds of questions like counting questions that are just too difficult to answer and too cognitively costly to actually calculate for us. And so these are also questions that we don't want to answer. And then finally, like I showed earlier, there are questions that violate what I call Grice's maxims, or what the community calls Grice's maxims. These are types of questions that are long, they're convoluted, that are just not part of the social norms that have been established. And so because of that, they won't be answering those types of questions. So okay. These are the kinds of questions that if your agent ends up answering or asking, that nobody's going to answer it. And if people ever stop answering its questions, it's going to stop learning.
Okay, Ranjay, I got a question here based on one on the chat. Very good question here. The question said, what happens if somebody answered falsely? For example, you see the color of that cake there, and you said, oh, it's actually a chocolate color. So wouldn't that eventually going to impact sort of like the misinformation part of it? And how do you potentially take care of certain amount of misinformation that might be collected that way, right?
Great question. So you know what, let's take a little segue. And let me talk about this particular part of the question. So you're completely right. If people ever answer incorrectly or ever give it false information, you can have a situation where the system ends up learning things that are just not true. And that's also really bad. So how do we mitigate such a problem? Well, we began exploring that, and we wanted to see what are the kinds of interactions that people typically engage in if you have a machine asking them questions. And we wanted to see if there are particular kinds of questions that result in bad behavior from people, or if there are particular kinds of interactions that result in bad behaviors. And what we found was very interesting. We found that it doesn't matter what question you ask. That usually isn't an indicating factor. And it also doesn't matter who you ask. Most people are actually really nice, and most people want to help. What really matters is how they perceive you. So the way you present yourself is what really matters at the end of the day. So, for example, there's you could introduce yourself before you ask a question. So your agent can say, I'm an artificial intelligence, and then it can ask, what is in front of the elephant? Now, that's one way to introduce yourself. But we've found in a lot of psychology literature that people typically make judgments of others using what is often called a stereotype content model. It's a framework in social psychology that sort of explains how we form sort of opinions of other people. So the two main axes in the stereotype content model are competence and warmth. So competence is typically how competent someone is, and warmth is how nice they are. And at any given second, you're making judgments about other people's competence and warmth. So the moment I started speaking, for example, you made a judgment about my competence and warmth as well. And this is something we do from every single interaction we have with people within a few milliseconds, okay? And the way you introduce yourself completely changes the way people sort of perceive you, because they will place you in different quadrants along these two axes of competence and warmth. In most of the time, what we do as people is that we try to introduce ourselves to be high warmth and high competence. And so a lot of machines today are also introduced as high warmth and high competence. But that's surprisingly not a good idea. So it turns out that machines that introduce themselves as high competence are going to get really bad interactions. It'll have people more likely to give you fake information and mislead you because they think, oh, you're competent, you'll just figure it out. You don't need my help. It's more fun to just sort of give you the wrong thing.
Right.
Whereas if you project low competence and high warmth, then people automatically treat you like they would treat a baby. They want to help you. They want to help you learn. And it's the same thing that we see with AI systems as well, that if you project low competence and high warmth, people are more likely to spend more time with you, and they're also more likely to give you good responses. So saying that you're an AI system is a bad idea, but introducing yourself as maybe a research project that is trying to learn about the world, that's a good way to introduce yourself. And so that's how we sort of ended up preventing the problem of getting bad data.
But how is that your robot going to smile? I mean, a smile matters, right? If you look at it, right, from a warmth point of view, how would you communicate that there?
Right, that's a good question. So the way sort of to think about that question is you're asking about smile, and you're making a judgment on someone's competence and worth based on their physical, visual features. But there's a lot of other factors that really affect the way you make judgments of other people. So, for example, if I tell you that someone's a shrewd businessman, where do you think you would place them on this competence and warmth axis?
Are you asking me?
Yeah, sure, or anybody. Or anybody. Where do you think you would put them? If I said someone was a shrewd businessman, where would you put them?
Probably skillful, intelligent, potentially depends, I think, but again, shrewd businessmen does not necessarily mean they always show they are intelligent. And that's my personal experience of knowing people who are extremely successful in some ways, so financially also is very, very, that's a beauty of, and maybe there's a cultural element to it a little bit, but that's my
Definitely is,
experience, at least in the US, so I've had billionaires standing next to me I didn't know, for example, right?
Okay, so you would say shrewd businessman is high competence, somewhere in the higher range.
High competence,
what
but
about,
they may
what
not
about
show
warmth?
it, right?
Sure.
Yeah, right.
Where do you think the warmth is for them?
I think they, it kind of varies. I think the warmth part of, from, it can vary in different ways. The ones I met, has a good warmth in it, in terms of communicating that actually. But that may not be true for everybody. I think it, maybe I'm making a different sort of adjustment. It depends partly on the field where you're successful in. Somebody in Wall Street who is successful will be very different than somebody in the tech industry, for example. So, so you can see that sort of a different warmth in terms of an intelligence and what it is that you're going to come. At some point, I think your system is probably wanting, maybe you're already figuring that out, coming to this place, right? So that are additional dimension to this sort of a two-dimensional view of looking at something that might factor in. And the percentage of how much that will factor in, it's probably going to be very, very difficult or subtle at this point to know. So that's my kind of a rudimentary thoughts on it right now. So
okay, let's try another one. Okay, let's try one more.
I'm the robot playing against you now, or what's the deal right now?
Yeah, I just want to see where your thoughts are on
okay,
this.
Great.
Let's try one more. Okay? Let's try. How about a teenager, someone who's 16 years old, and I'm asking a default sort of average score. Where would you place an average teenager, not a particular teenager you've met, or specifically the teenagers that you've encountered, but just in general a teenager? Where would you put them in the competence versus warmth scale?
I would say probably more on the warmth scale at that age. So that would be my take on it,
Okay. And can you say anything about competence, or is that a little bit unclear?
At 16, the competence is, depends on what you start to have a conversation about, right? And that's where you sort of, not that you are trying to gauge the person, the teenager, how intelligent it is. That's not the point. But in terms of the level of interest, I really enjoy interacting with younger people, especially 10 and younger. I find them more interesting. But 16, it could be different. And so I guess I'm trying to punt your question.
You're giving me a very political answer, which is fine. I would put teenagers at definitely a lower end of the competence spectrum. The older you get, typically, the more competent you become. So I would put kids at the very left side. I'd put teenagers somewhere on the left side. I would put adults somewhere on the right side. And the older you get, I'd put them more and more on the right-hand side, on average. Again, not talking about anyone in particular. There are tons of exceptions to this rule. I'm mainly talking about stereotypes, right? This is the stereotype content model. And stereotypically, a teenager, on average, compared to a normal random person that you meet on the street, would be less competent than an average random person.
By the way, one
Um,
person commented hearing our discussion saying low warmth because some deviant behavior due to
I
recent
completely also agree with that too.
I don't sense
Maybe
at
the
that
teenagers you've
particular age.
encountered are high warmth, but the teenagers I've encountered are
Yeah.
definitely not high warmth. So,
Okay.
but
So
regardless,
I guess I have not talked to too many teenagers lately. So all right.
no, it's good. You have a more positive outlook towards all of this. But regardless, the point I was trying to make is that we can all make judgments of people without looking at them by simply having descriptions. So the words we use to describe things and describe people, that's all you need to really make judgments of other people. And you can easily do it for anything along these two axes. And you were right to also say that it is cultural. It is very cultural. In some cultures, a teenager would be considered more warm than others. But regardless, it doesn't matter. You don't need the visual component. All you need are the semantic sort of words associated with it to evoke those kinds of stereotypes. And similarly, if you just use the right words to describe an AI system, then that's all that matters. In fact, we use this theory that we built, and we studied how have people introduced AI systems out in the wild today. So a lot of you might be familiar with Siri, for example. So Apple's Siri. There's also Amazon's Alexa. There is Microsoft's Tay, and all of these sort of AI systems that have been introduced, they are all introduced with some words associated with it. So Siri is introduced as your assistant, as your personal assistant. And a personal assistant is usually considered relatively high warmth because it's personal. Assistant, typically, competence can go either way depending on how you view assistants. Now, Microsoft's Tay introduced Tay as Microsoft's fan that's got no chill. And those words typically evoke low warmth. And so, again, depending on what words you use, people react completely differently. And we found that our theory was able to predict how people were going to use these systems, whether they were going to be successful and whether they were going to be adopted or not. So regardless of what the underlying technology is, because the technology doesn't matter. The only thing that matters is the words you use to introduce your AI system. We can completely predict which systems will be adopted, which systems will not, regardless of the underlying AI technology. So that was kind of exciting. Of course, there are changes that would occur if your system is terrible versus very, very good. But overall, assuming that all the technology is about the same, the words you use completely change which ones are adopted. So Tay, for example, most of you haven't heard of because nobody adopted it. Right. Siri, a lot of people adopted it because it projected higher warmth. It's not very useful. I mean, most of us don't even use our Siris, but we know it's there. We have adopted it, even though it's useless. And it's because it's projected the right kinds of stereotypes. So that's typically how it works.
I think warmth definitely matters, just the way it is, even for, you think about, your, GPS maps, the sound and what it is, how the person talks, I mean, it's not as important as something like Siri or Alexa, but it does matter how it comes out to be, right? So,
right.
Yeah. Sorry, I'm not trying to distract you from where
No. I mean, this is what I'm here for. I really enjoy more of these questions more than the things that I have to say from my slides. So please feel free to interrupt me and ask me any questions you like.
I have one like a question kind of thing.
Sure.
It's a very nice topic and presentation, but we are seeing a lot of Hollywood movies that AI is kind of will reach a point when it will, like, there is something on a singularity, right?
Yeah.
So I mean, how far do you think will it really be something true, or it's just like a fantasy? Because we have seen, like, you talk something like Alexa and Siri, and there are some movies, like, they have this kind of AI with a lot of warmth, and they started to interfere with like human psychology, and they started to leave everything and just stay with the AI and that kind of stuff. Just curiosity.
Sure. Surprisingly, this is a question that most people in my field get asked quite often. So the way to answer this or think about this is nobody knows. And there's no evidence at all that we are ever going to have systems that are going to sort of rebel or reach that singularity necessarily. We're going to have systems that'll get better and better. But predicting what the future will look like, when something like that would even happen, where they would surpass any sort of behavior, general behavior, I think that's a fool's errand. No one really knows. Back in the 50s, Rumelhart, who was one of the sort of foundational people in AI, he wrote an article in 1957 where he described to the world his vision of an AI system. And he said we are about 10 years away from a perfect AI system. So that means by his projection, by 1967, that singularity should have happened. And then we had the exact same thing happen again in the 80s. And then we had the exact same thing happen again in 2012. And we're going to keep having this. Every time there's some new breakthrough that allows us to build something that's a little bit better, we're going to just assume that we've cracked it. And then in about 10 years, we're going to have this sort of singularity happen. It won't. I don't think it's something we need to worry about in our lifetime. And it's definitely not something that we should be dedicating our time and energy into. What we should be thinking about is more along the lines of the negative consequences of having automated systems. We have tons of automated systems today out in the world, and they typically end up dictating what our lives are going to be like. So for example, if you look on Instagram, for example, you'll see tons of photos like this. These are all from different people across different sort of demographics, but surprisingly, all of us like to take the exact same kinds of photos. And that's because the algorithms that are deciding what photos get shown have learned that people like these kinds of photos. So you see more of them. And because you see more of them, it changes your behavior. You start taking photos like this as well. So this is all just implicitly changing your behavior. The same thing happens with ads. Same thing happens with the kinds of people you talk to on Facebook. I mean, some of you even might be getting your news from Facebook, which is probably the worst thing you can do. Because the news that you're probably getting is probably false, because it's sort of buying into the notions that you already have and reinforcing them. Our world is completely being dictated by the sort of AI systems that are governing a lot of our digital spaces. And they end up changing our behaviors in the real world. So it's also affecting our physical.
That's a very good question. I mean, I can give a slightly different example, which is about watching movies and TVs, for example, to start with, how the actors and actresses sort of talk and whatnot. You can start seeing that more with the people doing it today than maybe 30, 40 years back. I mean, I can see that with when I go back to Assam, how I grew up, and going back 30 some years later, I can see a distinct different how people talk, and most of it is it is, I believe, is influenced by how the medium we watch and whatnot actually is there, and so that changes the behavior. Whether it is better or worse, I mean, you gave a very good example about the pictures like this, rowing pictures, right? People might think this is the only thing, and it can also happen about what we define as somebody is beautiful or not, for example, right? You might kind of said, okay, this is what we see. And second thing, you probably know, because you're in the field much more than I'm familiar with, but there is obviously a psychological factor to it, right? If you keep saying that this is better, then everybody will start thinking that's actually better. Whether it is actually better is still questionable potentially, so.
I think pictures in Instagram has, gave a false kind of idea to people about how someone should look or how someone should have go to gym. And, yeah, so, I mean, yeah, it's everyday life. Anyways.
And a lot of these underlying causes are the algorithms that end up dictating what you see and what you don't see.
Right.
So those sort of negative consequences, those are things we need to worry about, because they're affecting our world today. We have anti-vaxxer movements, we have flat Earth Society, all of these separate groups. They exist because of misinformation that is fed to them by these sort of social media sort of platforms that are out there. And all of them are being run by the same AI algorithm. And so really understanding the negative consequences of these kinds of systems, that's what we really should be focusing our efforts into. So we spend a lot of time thinking about regulations and what kinds of laws we need to enact to avoid these kinds of problems. Europe has done quite a lot of good work in terms of enacting laws in terms of having dark patterns being completely removed from the internet, for example. So dark patterns are pretty interesting if you don't know what those are. If you want to subscribe to something, let's say you want to subscribe to a newsletter or something and pay money, that's really easy to do. But unsubscribing is really, really hard because they hide that unsubscription button somewhere deep inside. In some cases, you need to call somebody up to even unsubscribe and stop paying for something. So these kinds of little patterns, the dark patterns, exist all across the internet, across many different companies that end up sort of tricking you into paying or using services that you don't want to use. And Europe has been really leading the charge in terms of regulating and preventing these patterns from being used. So we need to have more of those and more of these conversations around what are similar sort of dark patterns or behaviors that can emerge when you have AI systems in the loop.
I have one question.
Sure.
Regarding the data, like when you teach one algorithm, like how many sets of data you need to feed? For example, suppose you are using one algorithm for healthcare and you are feeding some X-ray data into the algorithm. So do you have kind of like study how many data you need for the algorithm to understand the pattern in the healthcare analysis or diagnosis? So just a general question.
Right. Yeah, that's a really good question, actually. So what you're describing right now is often called few-shot learning in the community. And the goal of that entire community is to use as little data as possible, so as few data points as possible to be able to learn. And so that community has been really, really growing over the last few years. And typically, for the longest time, when we did want to train something, it would require hundreds of thousands of labels to make anything meaningfully work. But today, in quite a lot of use cases, we only require 5 to 10 examples, especially for domains where we have a lot of similar kinds of data already available. The same isn't true for healthcare. I think healthcare and chest x-rays and those kinds of domains are still pretty difficult to find any data for. So they still require a lot of data collection processes, but that's improving over time. There's been a lot of sort of coalitions between multiple hospitals and universities across the United States and across China to gather healthcare data and make it more accessible so that we can train these larger systems. So it's changing. We're getting to a point where we need fewer and fewer data sets and data labels, but it's still pretty far away for domains like healthcare.
Okay, thank you.
Mm-hmm.
So Ranjay, I'm going to go back to your thing about trying to piecing it together, because you said that you were able to train in your abstract that they're able to do it pretty good. I mean, so I mean, what I want to know is a couple of things. One is from a challenges point of view in terms of the training part of it, that, you know, what sort of things and what sort of limitation you still foresee, because no system is perfect, you know. I mean, and you know that, I know that it's not, and that's the beauty of, that's the beauty of our field, because there's always something new to
there's
work.
always work to do.
There's always work to do, right? So so anyway, I wanted to throw it out there and see what you wanted to say on that. So
sure, let me sort of briefly in one slide tell you what the system looks like. Okay, and then I'll show you some examples of things it's learned, and then we'll also talk about the limitations. Okay, so like I was saying, traditionally, the way you sort of think about training systems is you collect a data set and then you train a model. It's very simple: collect a data set, train a model. Now we're going to, in our framework, we're going to start off with this initial setup, and then we're going to take this initial model and then we're going to deploy it out in the real world. And then in that real world, it'll eventually encounter something that it hasn't seen before. And then we're going to take that new image or visual input that it's seeing, and we're going to send it to our socially situated agent. So this is our socially situated AI agent that's going to look at the new visual stimuli coming in, and it's going to generate a question. And then if people respond to it, we're going to parse their response to find the answer to our question. And then we're going to take that answer and we're going to add it as a new concept in our training data set. And then we can retrain our model as we have more and more interactions with people. Now, the final piece of the puzzle. Yeah.
One quick question here, Ranjay, is that So I presume some kind of a statistical filtering, you might still do it there in terms of people lying about it. Okay, they said, I see an elephant in front of an elephant, sort of an answer, the misinformation part, right? Some kind of a, that sort of information, when you do this, system, you want to account for that by doing multiple measurements and stuff like that, or asking multiple folks to respond to that question, I presume. Did I get that?
So we found that we don't need to, because if you
That's
set up the
interesting.
expectations correctly, if you introduce yourself correctly, you actually don't need to do it.
I see.
We found only about 1 or 2 people who gave us false information out of 1 million interactions.
Wow, that's very interesting. That goes back to your idea about the warmth, basically. Then.
So warmth and low competence, that's what
Mhm.
you need to project. And as long as you're projecting that appropriately,
Okay.
people are not going to give you bad data. But it
Okay.
also depends on the cultural norms that have been established in the environment you want to go and ask questions in. If the
Mhm.
norms that are established are, very rude or very sort of adversarial, then you're not going to get good responses no matter how you introduce yourself. So
That's
for
correct.
example, Twitter is a terrible place to have conversations with people. I don't know if any of you are on Twitter, but I don't remember the last time I had any conversation with anybody on Twitter. Everyone just posts things and then other people like it, and that's it.
Yeah,
There's no actual meaningful conversations that happen.
that's correct. Right. And it goes in some tangents.
So if you did this whole thing on Twitter, it's not going to work. But if you do it on Instagram or Facebook, where people are more inclined to have these social connections, you will actually find that people don't give you back data.
So I have to remember about the warmth and okay, I got to remember that. So next time okay, all right. All right. So
and then the last piece of the puzzle is that every single interaction we have, we learn from it. So
Right.
anytime we fail at an interaction, we learn not to do it. And every time we succeed, we learn that we can do more of that. And so every interaction also teaches our agent to uncover what are good questions, what are good areas that people are interested in, what are bad ones.
Okay, there's a question here, Ranjay. It's from the same person, Ria Nayak. She has been asking good questions.
Yeah,
So
good questions.
will this model be place or environment sensitive, or can be used for all?
Yeah, that's a great question. It'll be completely sensitive to the specific environments, the specific kinds of things you want to learn. We don't have any system today that works generally across anything. This is the first system out there in the world that has been deployed where you can learn through natural conversations with people, real people in the real world. And we're still, nowhere near getting even this simple thing to work at a place where we can be reasonably comfortable building any product out of it. So what I've built is a system that's a prototype that shows that it is possible to learn, but there's a lot more sort of considerations that we still need to think about to make this possible. So this technology that I'm talking about today of learning from real interactions with the real people, it's not going to come to fruition anytime in the next 5 years or so. We still have a lot of problems that we need to solve to make it actually work.
It's still at a research stage. That's why it's a lot of fun too. And so, and that's, let me ask you one question here, Ranjay, which is to do with the amount of data you need and as well as the compute power. What sort of things you want to say for in terms of that, I guess.
Right. So for our use cases, we ended up requiring a few sort of 100,000 interactions to learn meaningful behavior. But as I was saying, the way you sort of learn over time, that's going to continue throughout the entire deployment. You're never going to stop learning. So what I'm advocating for are machine learning systems or AI systems that'll learn forever. So you'll never have a limit on how much data you need, because my argument is that no amount of data is enough. We need systems that will learn continuously over time, correct previous mistakes, and imbibe new information over and over. In terms of compute, you actually don't need much. We did all of this across 2 machines that we have in Stanford. They both have GPUs. So as long as you've got some really high intensive computers and only 2 of them, that's really all you need.
Wow, that's pretty impressive though. That's actually a good thing about it. That means it can be a few years down the road, you can push it into a couple of chips probably. 5-10
Yeah.
years to compute the whole thing and continually learn from it all the time. Then,
Yeah.
compute it, and learn from it. So very good. Okay, go ahead.
Yeah, I found that across all of my sort of experiments, whenever you want things to work in the real world, it's never the technology that's the problem. It's always the people. So understanding people and how they work and how they're going to react to things, the psychology behind how people interact, that often dictates everything. And the underlying technology, not very much.
So have you figured out how to interact with your parents by now? What did you say to them?
I don't know. I think they might be here, so maybe they can answer your question.
I think they are here, but they might not answer the questions. I don't know if they want to answer the questions.
Sir,
Rima, you want to answer
Excuse
the
me, sir.
question? Sorry, go ahead, Ria.
yes, sir. First of all, this is really very interesting session that is going on. I'm enjoying it a lot. And
Great.
secondly,
I'm happy to hear
I
that.
have just jotted down some of the points that you have mentioned about. So after so far listening to the discussion, I'd just like to know, like, does it have some of the limitations or not? Like, what is your take, like whatever nowadays is trending, like the data breach, data protection, privacy. So what is your take on this such topics like data protection, privacy, sensitization towards new challenges?
Mhm.
So how in such situation, how the model is going to react like? Could you
Yeah, so there are
explain
tons of challenges. They're both ethical challenges as well as, design decisions that we really need to think about. Let me see if I have any slides that I can talk to you about. For us, we ended up deploying this entire thing on social media. So there's quite a lot of questions around whether that's something that's worth doing at all. I mean, we wanted to just show that you can build a prototype that can learn from people. In no way am I advocating that we should deploy these things in social media or any specific domain in particular, because anytime you have a system that is only learning from a handful of places or a handful of people in a limited sort of area, it's going to get biased. They'll be biased by the people that are teaching it. So we need to overcome those issues. So that's one big one. Let's see, what else do I have here on this list? We talked a little bit about self-identification. Today, we have a lot of systems that actually are quietly affecting your behavior. And so all of these, I would advocate for self-identification. So I'm identifying where they are, what they're doing, how they're affecting your behavior, how they're going to change what you see. That's something we need to have more of. We also need to think about risks associated with diverting people's attention. So if I want machines out in the world that are learning from people, if people are going to teach it something, it's an opportunity cost for them to teach someone instead of doing something else, right? So we need to think about that. We need to think about what it means to divert someone's attention, and is it really worth it? Is it really worth you learning what a rhino is if it means that somebody loses another minute of their life? So we don't know the answers to these questions. And these are sort of questions that we need to really think about depending on the domain and the kinds of things we want to learn. Then there's, of course, malicious use of these kinds of technologies. So I'm telling you about a very benign case where I'm trying to learn about rhinos and simple things out in the world. But you can use this exact same system and learn about your private sort of preferences. We can learn about where you live, your hometown, your social security number, all kinds of things. And then we have a lot of information about you. And at that point, we can use that information for a variety of other nefarious sort of applications. So there's quite a lot of risks associated with malicious use of this kind of technology. And then we talked already a little bit about biases that already exist in the world, and having systems that learn from people will only amplify the biases that already exist in people. So how do you mitigate that? That's another big problem. So there are people working on different components of this. And these kinds of problems will become more and more pronounced as our algorithms and as our machines get stronger and stronger as we progress technologically.
So is it governed by the California data privacy law, the CCPA?
So all the things that I build are, but that doesn't mean that the underlying technology itself can't be repurposed for any other use case. So everything that I work on is publicly sort of distributed online, but anyone can pick it up and use it for anything else they want.
Thank you.
So there's a question that what are the practical applications from one of our friends of Visit Burua? So where do we
Oh, yeah.
see something like that being used more likely than other places? Do you have some thoughts on it?
Right. Yeah, absolutely. Let me see again if I can find the right slide for this. I'm really enjoying all of the questions. So ignore the right-hand side with the graph, but let's just focus on the left-hand side. So we've got here are some examples of things that it ends up learning after we deploy it out on Instagram over a long period of time. Now, this is exciting because it's learned things that are normally really difficult for people to answer. So that bird on the top, not a lot of people know that's a magpie. But if you've encountered that bird and you've taken a picture of it and you posted it online, it's more likely that you know what that bird is. So technologies like this that can ask questions can find the right person to ask the question to. And we can learn things that are very, very specific that not a lot of people know. But we can find the people who know it and learn that information. So that's really powerful because not only can you do this for categorizing very specific kinds of things like birds, but now you can talk to doctors when you encounter things that you haven't seen before. And you learn about diseases that are rare because they come up and you can ask somebody about it. So again, just like people learn and they learn about all kinds of things in the world, these machines can now have the same capability of learning very, very specialized information that not a lot of people know. And collecting data sets for these specialized cases is impossible to do because we need to pay experts a lot of money and we need a lot of data. It's really difficult. But if machines have the capability of learning them on the job while they're out being deployed, then that enables a whole host of new kinds of applications.
But Ranjay, this brings up a very interesting point here. We talked about people not telling the truth or whatever, but typically my experience is that if you go to an expert and ask a question, they will tell you the truth. Like the way you just talked about the bird. Who knows about this bird? They're not going to lie about it. Not that they have any interest, but they are not that they're trying to show off that they know about this bird, but they're going to say, I know what this bird is. I had the same situation. I took a picture. I used a bird app to try to figure out what it was. And I had a hard time because it says it's not in the Midwest where I live, right? And this bird. And so I said, finally I said, maybe it is what it is. I'll show it to you. But I think there might be a, if the system that you kind of think about also has the ability to realize that, I guess it partly comes from a type of a question, like this example of your bird you were talking about. What kind of a bird is that, right? So with that one, what happens then is that I know about it, I'm going to tell you. It's possible somebody might guess it. There are people who seems to know everything on Earth, right? So you cannot rule that out. But the probability, if you look at it as a probability problem, then you can kind of see that most likely you're going to get the right answer on those kind of a very special sort of things, right? So, I mean, going back to my friend Avijit Buro, who asked the question about practical, he's a, produces oxygen in Guwahati, right? So if you're asking something about how to make this very high quality, 99.99%, he's not going to tell you the wrong thing. He's going to tell you the right thing there, right? So, so I guess maybe framing of the question matters sometimes. And of course, that the context matters to be able to get hopefully the sort of the type of answers. Then that helps to build a better model in terms of training it. Does it make sense?
It makes sense. Yeah.
I'm trying to learn from you. You see, are you getting there?
I'm learning from this conversation.
so I'm trying to learn from, I always try to learn from other people. So what they're thinking.
And we learn from all disciplines, right? So behavioral data science.
So, but actually that brings up a question I have. So it's more a question of the way we as a human being get trained. So I'm going to kind of shift gear here for a second, Ranjay.
Sure.
Is that we are going to train in a certain way because of our abilities. Maybe you're good in math or you're good in history and whatnot, right? So, and then with our educational system where it is very kind of a, score oriented, and the spectrum varies from whether it is in India versus China versus US, but it's sort of a training system, or a human beings are basically sort of has a way that trained us. Okay, so I'll tell you where I'm going with the question here. The question here is that if I'm trained that way and I want to build a new AI model, like the way you are trying to think about it, you almost always have to think outside the box, because otherwise, you might be. So I will now kind of hone it down a little bit more. So, my experience of people, I know in computer science are all techie people, really, really bright people. They're nothing against them, but they are not. There are certain things they don't think about. It's not that. It's because that's how they're trained. The mathematical training and everything, right? But
Right.
but to solve certain type of problems, you have to kind of step outside the box to be able to
Right.
look at it.
Yep.
So if you now think about the whole educational system from that kind of a perspective now, looking at from your lens, I'm calling it your model, the lens right now, that means what is that we need to somehow figure out where to step out the box so that we know that it's a rhino sitting out there in front of the elephant, right? So I'm not expecting an answer from you, but I'm just trying to see is there something we need to kind of feed back to the educational system because of the way we have been trained so that we can train better things for the future.
Right. No, absolutely. So in fact, funnily enough, I'm reading this book right now, The ABCs of Learning, ABCs of How We Learn. So I do spend a lot of time thinking about education and how we should be training people, not just AI systems. And for those of you interested, I teach 2 courses at Stanford. Both the courses are, of course, pretty technical math courses, but they draw a lot from neuroscience, cognitive science, psychology, and other areas of human behavior and development. And I make it a point to make sure that when I'm teaching these courses, I'm thinking about what are the things that I want people to know, especially people who are going to be going out and developing these AI systems to begin with. In fact, a lot of my papers, if you take a look at my publications, they involve authors from all across disciplines. The best way to sort of fix any of these issues or tackle any of these issues is by knowing that you can't tackle them as technologists or computer scientists. You need people from all across the spectrum. So in all of my papers, I always have professors or folks from communications, psychology, from law, from business school. They're all sort of involved in one way or the other, depending on the project, of course. And working at that intersection, working at the intersection of multiple disciplines, that's where we're going to start making progress. And that's how we're going to build the right kinds of systems.
No, that's a very, very interesting point about training and interacting. I can tell you my own experience of when I first worked at Bell Labs 30-some years back after doing my PhD, right? And I thought it'll be all technical people. There are people with PhD in history, people with PhD in psychology. At first I was a bit confused, right? But I realized that that's sort of a thing, different way to look at a problem, even in a technical problem of all this different background, actually makes solve the problem better, rather than what it is. So what you are saying is kind of resonating with me right now because of my own experience and how that changed me, how I teach and over the years, and how I do different type of things, what my interest and how it has evolved, and obviously people have gotten to know at a personal level from different background, so that's sort of very, very interesting. There's a question here. I don't want to kind of go there without leaving out this question. It's a basic question. With AI, will people end up having control over the machines in the coming age? And second question, whether frequent check and clean could be a measure to keep it under control?
Yeah, that's a good question. I would actually argue that we don't have any control of the AI systems we already have today.
Right. I completely agree.
Nobody knows how Facebook's algorithm works. I've had tons of conversations with people who used to design what you typically used to see on Instagram's For You page whenever you went on it. or explore page. And they were all eventually fired because the models that they were developing were doing better at getting people's attention and getting them to use the app more often. And that's what they cared about. That's what they sort of optimized for. But at the end of the day, nobody really knows what these models are actually doing. So one of the things that I've been working on over the last couple of years, I didn't get to talk about any of that today, is really thinking about what are the sort of characteristics of intelligence that we possess that allows us to sort of overcome these sort of biases and problems that exist in the world. So developing ideas like compositionality, causality, understanding why and when things fail and why they're behaving certain ways, thinking about interpretability in these AI systems, that's the kind of things that I typically work on quite a bit. And that's going to become more and more fundamental as these models get more and more broadly deployed.
Very good. Let's see if anybody else have questions. We're almost at an hour, so maybe a few more minutes for any additional questions from anybody.
I would like to
Unmute yourself to ask the question. Go ahead. Yep.
Yeah, I would like to add a small point to the practical use of AI. So I am basically a coral reef student. I study the marine ecosystem, and we have something known as the coral net. So coral net is basically AI. So what we have to do is we take the pictures of the coral reef and we try to find what species is there in which area. So what CoralNet does is that we measure the percentage cover of the corals and different species, and eventually when we reach a point where the AI takes over and it does that for us. So of course we have to check that. We have to keep a check of that because it again depends on the person who initially entered the information. Because based on if he's very talented, then I mean it was developed by UCLA. San Diego, and it's basically a online platform where we have to put our image and that the AI does it for us after a point of time. That's one application, but it's still under development, so they are still coming up with new things and all. So yeah, that's all.
Good. Thank you.
Thank you.
Anybody else have any other questions? Okay. Okay, there's another. Okay, there's another question here. So something about taxes. We cannot get it without using AI on taxes. So for example, AI used by tax authorities, will it assume that taxpayers would try to dodge the system? So, so
yeah, so, well, I think there's a more fundamental issue here. It might, right? It might assume that people might dodge particular kinds of payments, but I think this problem gets worse when you think about what kinds of demographics it's going to target and assume is not going to pay versus others that it thinks are going to pay, right? So maybe people from a particular state, it might think that, oh, you're from that state. Those people from that state they don't pay their taxes. So perhaps there's sort of inherent biases these models are going to learn, and that's going to prevent them from giving out, I don't know, whatever they're doing. So it might end up making predictions that are maybe unfair to entire demographics of people. And we've seen that already happen. There's entire demographics that are completely alienated when it comes to what kinds of loans they're allowed to have. And similarly, I mean, the same kinds of problems would probably apply for taxation as well. We've also seen the same thing for policing and criminal justice as well. All of that is going to be a big problem. So having actual systems that are evaluated appropriately, so we know that these kinds of problems exist, that's another big challenge. There's a whole host of folks working on fairness and defining what it means to be fair, both from a theoretical perspective, but also from the perspective of law. And we are trying to build better models. But things are just moving faster than we're actually solving. Correct.
And especially, and then of course, the continually learning models are going to be very important, because if you do fixed in time, people will find workaround, right? Because then it's, like the example about the taxes, some areas people do it this way, then everybody's going to try to, so people will find some, some other ways to go around. Is there any other question? If not, I have a last question for Ranjay, actually.
Sure.
So the last question for Ranjay is that do you consider yourself a scientist or a philosopher?
I'm a scientist. At the end of the day, you're defined by the tools and frameworks you use to conduct your work. And the framework that I often use is a very, very scientific framework. I come up with hypotheses, and then I design studies, I design models to test those hypotheses. And that's a scientific approach. And then I publish them in with the results. So it's a very quantitative science approach that I take to solving these issues. I am by far not a philosopher in any means, but I do collaborate with philosophers because they have some very interesting thoughts on how things should be.
Now that's what sort of what I expected you were going to answer, but I still wanted to ask that because the reason I ask it is that many of the problems you're looking at has a philosophical context to it. That doesn't mean that you don't take a scientific approach to the problem, right? You know, there's the whole thing about something fair being, you know, or you know, are you accurately being able to do something, right? So there's a context to that. That doesn't mean that you're not taking a scientific way to look at the problem, because
Right. Oftentimes, the way we sort of tackle these issues is we identify the domains in which we're going to study them, make assumptions. And those assumptions, as long as those are valid, we try to come up with solutions.
Exactly.
But of course, those assumptions aren't always valid.
Right.
So knowing when to use the kinds of things that we typically end up using or developing, that's also very, very important.
Great. All right. Very good, Ranjay. Thank you so much for your time. It's great chatting.
Of course, happy to be here.
And so with this, we're going to stop it here. Okay. Hope everybody enjoyed it. And so we'll be in touch. Okay?
Yeah, thank you all for coming.
Okay.